So once again, welcome everyone to today's webinar by Inland Software. This one is titled Hazard Analysis and Functional Safety Compliance. And today we will be talking about how to apply a systematic and structured approach to analyzing hazards and risks in product development to achieve compliance with regulations, specifically in the automotive industry. My name is Christoph Horvat, and I work with the Inland's marketing team. I will be moderating today's webinar. The host of today's session is Adela Beres, who's our functional safety expert. So Adela has worked with renowned companies including Robert Bosch and ThyssenKrupp in the past, and more recently she has spent time at automotive, an innovative automotive startup that's involved in developing self-driving technology. It's a leading-edge company. And as our functional safety expert, Adela will be hosting our webinars of the Functional Safety Summer Academy that we're hosting this summer, which I will tell you more about in a minute. But first, let's start with a quick overview of today's agenda. So first off, Adela is going to introduce us to some of the basic terms and definitions related to functional safety and hazard analysis. And then we will be talking about the general role, as well as the practical details of carrying out hazard analysis and risk assessment in automotive development. We'll also touch on the topic of safety goals and ASIL values, and we'll cover the difference between verification and validation, but not much more on that topic because it's going to be covered more extensively in our upcoming webinars. And after all this, Adela will show us how application lifecycle management can help carry out hazard analysis and risk assessment in practice. A bit more information about today's webinar. So we should have some time at the end for questions. But if we do happen to run out of time, don't worry about it. We will just take it offline and answer your questions via email. So as usual, just use the questions box on your GoToWebinar control panel, which should be on the right-hand side of your screen. Just look for the questions box there and submit your questions anytime during the session. Don't worry about it, you're not going to interrupt anything, and we'll be reviewing those questions at the end. We'll do our best to answer them either on air or, as I said, by email after a session. And please also note that this webinar is being recorded and the video will be posted on our website soon after the webinar so that you can share it with your team. And so just before we start today's session, let me take a minute to talk about our expert series this summer. So today's session is actually part of Inland's Functional Safety Summer Academy, which is an expert series of 4 webinars on functional safety. Right, so why did we feel the need to organize these webinars? Well, those that follow Inland Software's story and success may already know that our ALM platform, Codebeamer, is being increasingly used by safety-critical product developers. And specifically, we have recently had a few great customer wins in the automotive sector, which is one of our core markets. And as we are winning these deals, as we're having closer and closer relationships with automotive innovators, we're building up some serious domain knowledge of product development in this field. Now, all that knowledge is being built into our templates and services so as to better support our current and our future customers. And we are now seeing an increased focus on functional safety across industries, but even more so, of course, in the automotive sector. As development life cycles accelerate and new technologies are being built into everyday products, there's a lot of emphasis on ensuring functional safety and on ensuring functional safety in an efficient manner with the least amount of resources. And that is exactly where we see the main value of our application lifecycle management platform, Codebeamer ALM. And so Inland Software offers industry expertise, support, and pre-configured templates to help you reduce the time and effort costs of managing functional safety. So we wanted to go ahead and take the initiative to teach and train both current and prospective users of our tool. And our goal with Inland's Functional Safety Summer Academy is to share some of the best practices on using ALM to manage functional safety and to achieve compliance in safety-critical markets with a focus, of course, on the automotive industry. All of these webinars are free to attend as usual, so just go ahead and sign up for them, and we'll be happy to have you. Right, and so we're getting ready to start the webinar. One last thing I'd like to do before we do that is ask you one question, which is whether or not your product portfolio contains safety critical items. So are you developing safety critical products or not? Right, as expected, I can see that an overwhelming majority of the attendees today are actually in the business of developing safety critical products. Thanks a lot for your answers, and now it's time for me to pass it on to Adela, and we can start the session. Adela, are you ready?
Yes.
Okay, there we go. You should be presenting now. I still can see your screen. Try once again.
You cannot?
Don't worry about it. Let me just pass it on again, maybe this way.
Yeah.
There
Okay.
we go. Okay, you can start.
Right. So welcome, everyone. My name is Adela Beres. I'm a functional safety expert in automotive. And today I will talk about the hazard analysis and risk assessment in accordance with ISO 26262. We will have a short theoretical overview just to be on the same level of understanding. And after that, I will show you how you can use Codebeamer to support and manage your activities in this field. Okay, so since we are talking about automotive and safety, let's just say what safety is. Well, safety is shortly an absence of unreasonable risk, which is more or less defined by society. And the goal is to minimize the hazardous incidents and accidents by some systematic approach. It is defined by ISO 26262. Today, we all know that vehicles are getting more complex and they are starting to be connected. We are talking about small products, Internet of Things, it's all coming together. So I know that the conventional ISO is really focusing on conventional items, and today it's not so straightforward just to sit down and define what my item is doing, and which is like the first step to perform a hazard analysis. Okay, then just shortly some definitions and about the methodology. Okay, so the hazard analysis, it's a method to identify and categorize hazardous events that are caused by some malfunction of an item. And at the end of the day, we want to avoid unreasonable risk, right? It is a potential source of harm of a person, and it's caused by the malfunction of the item. Typically, we're talking about E/E, so electric failure, but I will talk about that a little bit later. And just one more important definition about the item, which is now changing nowadays. Typically, when we are thinking about an item, we should think about a sensor, or we should think about a functionality we want to analyze. And normally, it should consist at least of a sensor, a controller, and of an actuator that are interacting with each other. These functions are today getting more and more complex. So I know that lots of companies have issues with it, just how to define the boundaries of the analysis. But basically, what you want to do is to understand the boundaries of your item, so of the system that you are developing. And when you did that, then you can actually perform the hazard analysis and risk assessment, where you will define your ASILs. And from that, you will derive your safety goals and additional information you will be needed to perform and have your first functional safety concept. But that will be the topic of next webinars. I just listed it here because it's kind of a joint definitions in ISO 26262 in the concept phase. We are quite in the beginning, but I would like to ask you an additional question. So if you would just take a minute to answer it, it would be very useful for us. Okay. So we will wait a few seconds more. Okay. Right. So thank you very much for the answers. As I have expected, most of the companies are using some Excel, most likely. I see some companies are not using anything, so probably they are at the beginning of the development. So yeah, it could be an interesting. Okay, thank you very much. So let's just go into the details. So as I said, first of all, you want to understand your product. It maybe sounds simple, but you really need to define your item. So you have to know what its purpose is, of course, and you want to focus on functional and non-functional requirements. If you already have some knowledge from previous projects, then you should list already the safety requirements that could help you in the further analysis. You should know your operating and environmental constraints. They will, of course, have an impact on your functionality and also on the functional failures. You want to understand your boundary interfaces and, if relevant, human-machine interface, etc. So once you understood what you want to do on high level, you will take your high-level functional requirements. So I always say it's just a very simple statement. So, for example, if you are developing a braking system or a steering system, then you just want the system to brake or to steer when and how you want to do it. And now you want to find your hazards, so your functional failures. Of course, you can use your previous experience and checklists, but if you're doing it from scratch, which is could be typical to some companies today that are focusing more on developing self-driving cars and high-level ADAS functions, etc. So you can just start from zero and use the typical guide words that are used also in other areas as an FME or hazard analysis. So you just take the guide words and start to modify your required intended functionality and see what you will come up with. So you will have a quite big list, and you will see immediately that some of the deviations could be merged. And you should do that because you don't want to work with too many functional failures further on. Here, what I want to highlight is that even if ISO 26262 is focusing on EE malfunctioning of an item, so electric, when you are performing a hazard analysis, you want to focus also on other technologies that are in. You will receive a safety goal, so you will formulate a safety goal from that, but you will not use it further during the development in accordance with ISO 26262 because they are not relevant to ISO. But you simply have to take care of those high-level requirements or safety requirements in other technologies, so using other standards. Okay, so now we know our function, now we know our functional failure. And in hazard analysis, what we're doing is that we're putting these functional failures into a context. So checking this failure, how it will behave in a variety of situations. It's really up to you, up to the company, how you will manage these situations, how will you group them. But typically, you can use some vehicle state or driver's actions that are really more relevant to the vehicle. So you can see that you have engine on off, or the vehicle is accelerating, decelerating, etc. But you can use also maneuvers, so driving situations like overtaking or turning in a city, or just parking a maneuver, or sometimes you have to do an invasive maneuver, etc. So you can combine these, and then you can go further on. You can add environmental conditions, and you can define some road surface. So of course there are items where lots of these listed attributes are not important, but on the other hand, in other items, they could be really relevant. So it's really necessary to have a good engineering judgment and to use previous experience if possible, just to really list all the relevant situations and not to list the non-relevant, because you will end up with a huge analysis document at the end. Okay. So what you're doing, very simple. You take the relevant situation you are working with, you take your functional failure, so the hazard, and start to evaluate the two. So you evaluate the severity, the exposure, and the controllability. These are, of course, given in ISO. I know that lots of companies have issues with analysis, because it's, even if there are tables, it's quite subjective analysis. So it should be done in groups, and as I said, previous experience could help a lot. Based on the tables, you will determine your ASIL for each situation, if necessary, if you were not able to group already in the beginning some of the situations, just not to have too many combinations. And of course, later on, when you have the relevant hazardous situations, you will start to define your full-term time interval. But I will talk about that just in a minute. What I want to highlight is that, of course, we are talking about high-level requirements, high-level analysis, but yes, you should know that a fault that is causing these deviations, it's always happening on low level. So there is a hardware part, a conductor, a resistor, something that failed, and it will cause a functional failure that will propagate or not. But if it propagates to the boundaries of a vehicle, then we can talk about hazardous situation. It's actually done because there is a human factor, there's a driver that will evaluate basically the situation. Simply the tables that are given in ISO are, the controllability part is really connected to the driver, so connected to the user of the vehicle. So this is why there's a small difference between the low-level functional failure at what we are analyzing on this high level. Okay, so just a short summary. As I said, what you see in take the hazard as a functional failure, you should have very few, and then you combine with all the situations you think that might be relevant. You take the tables from ISO 26262, and you determine your ASIL for each. So when you have the hazard, there's one particular situation listed here. You formulate a safety goal from it. So now just shortly what the ASIL means, right? So I'm quite sure that every one of you knows it, but it's simply just a list of activities, plainly said, that you have to perform to avoid unreasonable risk, right? It's by definition. But the point is that once you determine the hazard, as the ASIL of the hazard, it will be inherited by the safety goal, and it should be inherited down to the atomic requirement level if the ASIL will not be decomposed later on in the analysis, but it's another topic. Okay. So safety goals, you don't want to have too many safety goals. I'm repeating myself, but it's really important because one additional safety goal can really increase dramatically your development in the later phases. So one hazard defines one safety goal, you will attach the ASIL and the full-term time interval. And what's important that you have to define your safe state, your degraded mode, your some emergency operation, anything that could be relevant for your functional safety concept later on. Since the safety goals are actually high-level functional requirements, they should be managed according to requirements engineering, and it's also described in ISO 26262. So what attributes should be added and what the context should be, it's also given in ISO. Okay, what I would like just as a final thought to say here is that, of course, the hazard analysis should be verified, right? It can be checked if it is complete, if it was done in accordance with some internal guidelines or in accordance with ISO 26262. But if it is correct, then we have to say we have to validate it. So we are validating the safety goals. It means that most likely you will have to sit in a vehicle and perform some fault injection tests and see if you really covered and had proper assumptions on the safety goals you will work on further on. The same goes for the determination for the full-term time interval. Okay, so this was the introduction. Now, before we go to Codebeamer, I would like to ask you 2 more questions, if possible. Okay. Okay, thank you very much. And just one more question. Right, okay, thank you so much. Now I will switch to Codebeamer. So here I would like to show you shortly what you can do, how you can use it. Of course, as we heard, there are templates that can guide you, but just keep in mind that so it's a very flexible tool as well. So you can use it really in a variety of ways. What's very good that you have an integrated wiki page where you can actually collect your thoughts. We loaded here some information from ISO. If you're performing this analysis, that just you can check for any necessary information. Just want to check if you had the proper ASIL, and we also included the tables from ISO. As I said, these are just information that you can extend in accordance with your internal guidelines or experience within the company. And here you can find just like a mini example of one possible architecture to perform an analysis. Of course, it can be changed. You can use more tables. This is just a compact overview, which is good if you don't want to miss any relevant combination during the analysis. So, for example, you can list the guide words. Then you can add additional aspects as the operational situation, operating mode, environmental condition, road surface, etc. And you can describe your deviation. There will be, of course, situations that are not relevant, not applicable to that situation. But I say if you are doing this for the first time, normally it is good if you document all your thoughts and just say that simply these combinations are merged, or this combination is not applicable, etc. So not to repeat yourself if you go back in other projects to the same analysis. All relevant combinations will then be evaluated based on the table. So you will provide the severity, exposure, and controllability attributes that will then define your ASIL. And so I didn't mention it, but I think it's important for the companies that didn't perform until now. So in the past, I got this question a lot. So the exposure, it's not actually probability of failure of your item. It's really the probability of a maneuver or situation the vehicle will be in. So some may argue here, but typically you should distinguish these two things. So on one hand, you are checking your function and your functional failure. That will have a probability of failure if you are talking about hardware failure. But the exposure here is really relevant for your driving situation. Okay, so when you have this table that can be really big, then, as I said, you want to merge the necessary information and come up with some really relevant combinations. Of course, that you will manage later on. Of course, you can manage all in the trackers, where you will actually be able to write down your relevant information, where you will be able to change your parameters. But what is mostly important that here these are like living items that you can connect. So whatever you have here, you will be able to connect to any test case further on, or to the safety goals, and etc. So this will be the part of your requirements management. So for example, you can just have an overview about what you are doing. It can also be written in very detailed way. You can have these details in a wiki page, so as you wish. But once you collected one hazardous situation that you think it's relevant, you see that you can change here, define the type. So we can say that it's for example safety analysis. If you want, you will be able to change that. It's really quite a flexible tool, but it is a proposal we are giving as a starting point. Then you can here change your guide word, your operational situation, anything that you might be list. So this list can be extended, and also these fields could be extended. So if you have another methodology in your company, then it can be really adjusted to that. Of course, here if you change the three factors that we are talking about, then yeah, for example, you say that it will never happen. If you save it, then you will see that the ASIL changed. So yeah, you can change here these parameters. And of course, I said in the beginning that once you have your hazard and you determine your ASIL, you have to validate it. So it can happen that you will need to change these parameters. So it's quite convenient if you can do it here, because you can actually go into more details on each item you define on these trackers. So among other attributes, you can check the history of it, and of course you can change the access rights and build a whole development process around it. So, but today I'm more talking about the methodology behind it. Once you have your relevant hazards, as I said, you then want to define your safety goals. You have a separate tracker for it. Of course, as I said, safety goals will have different attributes that you can change. So you can put the ASIL here, which should be inherited. So the first question is why is it not inherited? Or the point is that these templates could be used by different companies. Some companies will typically receive these requirements, so they will have to be able to simply write down those and change the ASIL. You can define here the safe state and the operating mode, so the state your system is in. And of course, you can change all of it and adjust to your concept and your internal processes. Of course, is the architecture is the same, so the engine behind, if you go into the details, you will be able to see the history of it, and you will be able to define any other attributes that are necessary for your process. The template defines by itself, but I want to highlight that it can be configured to your needs. What is, of course, relevant is that in any requirements engineering, that requirements should be linked. So you have to see what are the upstream and downstream references to your requirements, because you will further derive them down to functional safety requirements, technical safety requirements, etc. And that will be a part of another webinar. So I see that we are a little bit out of time. So this was shortly the how you can use CodeBeamer to manage your requirements and analysis. So please, if you have any questions, then just ask them. And if we have to close soon the session, but definitely we will answer you in a written form.
Yes, thank you, Adela. So let's try to answer a few questions. Again, please use the questions box on your GoToWebinar control panel. I can see one question. The user is asking, can I use this tool for different standards? Well, if you're asking in the context of automotive development, but even if you're not, the answer is yes. So essentially, the first part of my answer is the template, Intland's automotive template, supports compliance with ISO 26262, but also ASPICE and a variety of other automotive standards. But also, Intland offers pre-configured templates for the medical industry, pharmaceutical industry, and the aviation industry, which all come with pre-configured templates, workflows, etc., that help you comply with the relevant regulations in those industries. So the answer is yes.
Okay, there is one question that can the HERA attributes be changed, modified? So yes, as I said, you can adjust it to your needs. This is just an example that is covering, it could cover lots of situations, but of course, it's quite easy to add additional fields and extend the content of these fields. Okay.
So, Adele, do you think we have time for more questions, or should we take them offline? And
yeah, I think we will answer offline if that's fine.
Okay, I can see a few more questions. We'll just answer this by email. And also, a user has commented that my voice during the introduction wasn't really perfect. The connection wasn't perfect. I'm sorry about that. Must have been some technical issue. Hopefully, the video recording will have the introduction correctly as well. Okay, so once again, we're going to take this offline. We'll answer your questions by email. Thanks a lot for your attention, and please make sure you sign up for all the other events of our Functional Safety Summer Academy. Okay, thanks a lot. Goodbye.